Welcome to the second part of our practical lecture 0.1, short introduction to Python and Jupyter in our cloud computing and big data course. So in the first part of the course hours today, we had a little bit of a look on the difference between using Jupyter notebooks on a local machine, which means a local laptop. Something like Anaconda, a big package, has, for instance, Jupyter inside, but also NumPy, where we looked at pandas, scikit-learn, so many of the packages which are very, very relevant for data science and which are actually also ported to clouds. We will see about that. So basically, when you go to cloud computing environments like Amazon, MS Azure, Google Cloud, wherever you go, all of these packages and of course the access via Jupyter notebooks is also given there. So this is just more or less a warm-up for the course to think about that remote versus local plays a big role here. So the Anaconda distribution that you can download on yourself and play around to get some experience is basically usually local here on your laptop. You can see that by having localhost in your URI. Then we moved a little bit to the Jupyter JSC infrastructure in the Helmholtz Data Federation cloud that we have in Germany, just as one example, where we can control the environment a little bit, but basically where you are remotely executing Jupyter. And with this also have some certain elements to look at, which is also the learning experience you can have a little bit in the third lecture if you want, when you have to think about installation of some packages. Of course, while the cloud has maybe done some things for you already and installed all these packages you need, like MLX10, maybe for association rule mining, that we will actually touch on the second part here. It might be that on your local installation, you have to do that, right? Your own. But how you do this, I will tell you a little bit here with pip and so on. So let's go to the second part, which really should be, of course, also starting very simple for those few of you maybe today, which really just had never Python used before. There will be some very basic examples, but as I said, also I will here and there shift light on things I know that even more people that have Python used before always do wrong as well. So that's part of the second part here. Again, think about that we will, use now here on localhost the several ideas and the several examples. And by the way, I also actually loaded them already up in Canvas. So in the third course hours, you can load them if you installed Anaconda and play with them. But of course, they're so simple, you can almost copy paste it from slides in this sense to do something. So let's go right into practice. Basically, we go now into the Jupyter tool again that we had heard before on the local machine here, basically. And I already opened that just to make it proper. I want to also give you the idea if you basically open something like we had here already, the basic examples. If you remember in the last part of the course, make sure you properly handle this and say close and hold, so that essentially you have here a proper way of closing and opening them. This means a lot usually in the cloud. Of course, here in the local system, if you stop this Anaconda and Jupyter distribution part of Anaconda, of course, everything stops. In the cloud, that's not the case. And if you get not used to that of properly close a Jupyter notebook there, it will still execute and consume CPU hours. In other words, if you are in a commercial cloud, it pays, right? You have to pay. And it's something where it's lots of money is usually wasted by startups or so on, because they don't really properly shut down sometimes Jupyter notebooks. And this goes even along the way for really large Spark implementations, Spark farms and so on. But we come to this then in later parts of the course. But this is a very simple practice that is valid in the cloud, but also you should basically get this in your head when you do this here in the cloud course, always properly close and hold this. You see here one example. Now this is running this basic example. If you go to the general, to the overview of this directory, for instance, here, you see it green, it is running, basically, obviously, because we have another one. If we then properly do close and hold, we will see that it's then not anymore running. So the basic example is now, perhaps a bit too simple. I already showed something. The beauty is that we can really do this quickly with Shift Enter. We have this interesting strings that I was saying. Basically, this is a very nice idea. I said also usually the notebooks are from top to bottom, so don't hop around and then do suddenly, you know, here down there something, and then in the middle again, and then in the middle again. So this chaotic behavior in Jupyter notebooks, perhaps a deadline of an assignment is coming, is usually going to some mess in all the different parts. And I think one of the ideas was, I show you this just when we do this here, restart and clear the kernel, maybe. I show you this in a good example that we have here. We could maybe do this, and basically we execute this. But let's say we don't have here defined the languages, and then basically jump around. This executes nice, but this executes, oh, okay, there's languages. Okay, this is all here defined. That works. But when you now think about this, and sometimes it could be that the languages are even not defined. Like here, when you start it now, and basically you would introduce it here, but suddenly it's not here. And here you would just jump around and say, okay, we just execute this, boring, boring. Oops, languages are not defined. I mean, it's a bit artificial, this example. Think about that you have a large deep learning script, right, with 40 cells. And you hop around and you lose a little bit the overview. Where is actually languages now defined, where not? I thought it was defined here, but oops, I changed it. And this is the nature of data science. You change these Jupyter notebooks, you change usually the code, right? So hence, keep it more or less always, you know, step by step to really execute these elements, because otherwise you run into often troubles which could be easily solved because, you know, you didn't really define something. And you see that incredibly often also with experts in machine learning, right? That had basically some small modification done, and then think about that 10 down deeper in cells, there's a problem, and so forth. And this goes for many examples I do here, right? Obviously, in this simple example here, this is very clear. And you see here also a nice example with how loops can be very implemented very quickly here in Python, contrast to C or other languages maybe. It's very beautiful. You have your own data structure defined quickly with languages. For everyone in this language data structure, you want to print it out. That's clear. Python supports if-else statements very nicely. Based on this example, we could do now this particular example here, where let's say if we again kill that one and say, here we want to know for each of the languages, you know, print out everyone until we come to Iceland, because then I would like welcome you to Iceland. Then we have this basically here. Of course, if you do now execute it here, this is the same way. Just think about that the Italians are not here anymore, and it would break anyway at Icelandic here and not give out the Italian. But here you see quite nice constructs, how very quickly you can create a nice useful source code. The indents are important. I think this is also something useful here to understand, right? So we're talking here, this is the part of the for loop. So all of these different brackets that you know from many other languages can be a little bit omitted, but of course are also possible here and there. And maybe here and there makes also sense when you have larger programs. But in the end, a very nice language. The example shows it all, also quickly editing something like here. But of course, always take aware the message that when you change something here, like 3.5, and here is it 4.5, the one is a string, the one is a real computing, right? So this is obviously not correct. You really have to do the full editing of the full script. This is sometimes where I know people that are not in Python so much, or not so much in programming here and there, you know, do still some errors. This is one doing the real computation, the real math, so to speak. And this is nothing else than writing a string hard-coded. So there will be nothing executed, nothing changed. Also not if you do this, that automatically here will be a 4 times 5. But I think this is more or less basic knowledge. And I see already probably in some of your eyes, you know, that you start sleeping for those that know already a lot. But again, if there are errors around here, do a proper kernel restart and clear output. That is what I want to give you as an advice, also later for the cloud environments in MS Azure and Amazon and so forth. And then try to really close and hold. This will be having a different name every now and then, but the same idea is true. So you can restart the kernel, and similar things are actually true in Google Colab, which is a very similar environment, and then close and hold the notebook. Sometimes it's a bit quick here to close it. Then you basically can say stay on the page or so and close it again, and it will work. Good, so much for the first brilliant example really of Python. It really captures the essence why Python is nice, but obviously was not so insightful maybe. Let's go to a couple of vectors also there. It's a brilliant idea of quickly come to speed with data structures in Python, especially when you use it and combine it with NumPy, as I was alluding to in the first part of this lecture today. I would say mostly NumPy is almost always installed today. In remote cloud environments, in Anaconda, definitely, but wherever you go, chances are NumPy is there, so don't worry about this. It's different if you have ML extend, which we will look later in this association rule mining. And here you see basically a vector that has been generated with a proper dimension, 1 × 5. So you can see that nicely with these brackets. And the interesting thing is now when you think what looks like a vector maybe, where I've seen some assignments and so on where people think and try to understand it, well, that's a vector and it's not, right? So now you would think, Morris, you don't know a bit about linear algebra, but officially you would say this is just a 1 × something. It has not a proper dimension. It's just 5 numbers in a row, right? And even if you put it in the vector shape, you see that it has not a proper dimension to it. And which is the difference from here. Here it's clear, it's a 1.5 or 1 × 5, and here it's not. So, and this is an important trap that people that implement in TensorFlow or doing some other data science areas here and there and conversions of real data into data structures that algorithms and machine learning can swallow, really fall into traps with. So in this sense, here again, a real proper vector would look rather like this. You would have random number, but then specify properly the dimension. And you see here, the devil is sometimes in the detail. If you look at the source code from vector new versus vector, there's no big difference, right? We're talking about a 1 and comma in difference, and makes a huge difference in working with other data structures that expect a vector structure, while this is just random numbers. It's another idea that maybe I can give you as an idea of how not to do it, so to speak, or how to be careful when you implement. Another one I should, of course, mention is the case sensitivity, which is generally in basically in Python. A good way to know that is here with the libraries, for instance, NumPy and others, of course, have to be written in a very specific way. This is something what you also should basically really take by heart. And of course, the indents I already mentioned, we don't have them here, but is something also which is very unique Python to here and there maybe mesh up, especially if you copy paste, right? Several times people do copy paste, of course, examples from the web, which is not the big problem, but the web maybe has another indent or an idea how to do the indent, and then the indent is not really recognized in the Python, so to speak, in the interpreter when you execute it. This could be just copy and paste errors influencing your program. So I think the idea of this was a bit on the little things matter, right? Even if it's just case sensitivity, even if it's just here and there, you forget a little bit of saying it's a one-dimensional vector, which is obviously always the case in the vector, so to speak, and not a matrix, but that's just live in Python. Okay, so, and this is also uploaded for you if you want to play around with it. Close and halted, as I said, basically also maybe here and there do it a couple of times, coming to matrices maybe a little bit. And or as you want, it's a 2D tensor that you just learned, right? So nothing fancy about tensors, just another name really for multidimensional arrays, or as we have here, a proper 2D tensor, which is a nice matrix. And you see that again, because of these two brackets, right? And now we have here also proper dimensions to this data structure. And if you now do the same like the way we did before with the random, you see here also we define it by a proper dimension, and then have also again a proper matrix by having a, let's say, 2 times 5 here. And you see the brackets already recognize it as a matrix. This is also something, of course, as I said, it is in the end just a bracket, but it's important to realize that if you work with bigger data structures, especially if you are, let's say, in the data sciences and have to transfer from one data structure to the other, this could be, let's say, a bit tedious, and here and there, think about it, that's, yeah, sometimes an issue. But let's go back to the slides a little bit. I think I am boring you with too much basics here. I think Ingolfur probably covered that already to quite substantial degree, where many of you probably have been in his course already. And let's go to more interesting setups. And of course, when I do these kind of practicals, I try to show you always really the practicals as practicals, but I also kept a couple of slides always for you as a takeaway message, right? So we have for loops in basically in Python. We have if statements in Python. The indent matters, that's what I'm said. Make sure you have the case sensitivity. That's important. Exactly, and of course here the vector difference between numbers, the 2D matrices example, and so forth. But let us come now to maybe a next interesting example. By this, I want to also inject a little bit something which proved more and more useful. For instance, I had recently 2 master theses finished, which basically structured the thesis alongside the CRISP DM model. So this is an industry standard in terms of data mining. It's a reference system, so to speak, how to do data mining. And it's something I would encourage you to look at if you are, data science, and if you want to data science interested and want to do some projects. It always starts with some business understanding. Then you have the data understanding, some tasks, you really look into the data, try to understand it. Before you do some modeling or using some machine learning at all, I said to you, Python can be very helpful in the data preparation, not only in the exploration. So data understanding here is Python already very good in, we will see that actually in the example coming up, but also the data preparation. That's meaning bringing it in the right, maybe pandas data frames, bringing it in the right encoding for the algorithms to use it in the modeling. And then you, of course, you do an evaluation and you maybe think, okay, the model that we did was not really good. So what is the model really we want to do? What is it really bringing us the same understanding that we wanted? Maybe not. So you go back and forth with these phases, of course, every now and then to really, maybe here you see also back and forth. You have another model, maybe you have to put the data in SVMs differently than random forests. You encode a neural network, for instance, also different, especially if you have a 2D image that you have to vectorize first, maybe for a neural network, but not for a convolutional neural network. So there are lots of different things here which matter in order to prepare the modeling, and often there Python is to the rescue. Now, if you're then satisfied in the evaluation, you can go to the deployment, make your big, let's say, system and a server there for inference in a bank and receive your check of $1 million per month, if you're lucky. And this is a kind of general system or general idea how you have the different steps in data mining. We also do this a little bit in our assignment to understand it a bit better. And let me demonstrate now a little bit one part of it, which means the data understanding and data preparation part. We come to the modeling and other parts later in the course. So here we focus now today in the CRISP DM phase, really on the data understanding part and data preparation part. And before we touch base on the business understanding for just one slide or two. We will demonstrate this basically in the Jupyter JSC environment, where we basically have an interesting script that is there for pre-processing this so-called MNIST dataset. I already uploaded this pre-processing script and you have also access to the script. So let's go with the business understanding. So here the idea is that in the pre-processing we want to do now with Python and with the overall idea in the business, what we want to do with this data is, of course, to recognize handwritten characters. So this is originally coming from a data set with lots of different numbers. Obviously, it's a 10 classification problems. There are 10 different digits, right, from 0 up to 9. And we want to identify them automatically with machine learning. So this is our business understanding part, right? Of course, to understand this a bit more, what it really means, what we have to do, we have to dive deeper. And this brings us to the data understanding part. So what is the data understanding here? I want to know how I get the data. So the beauty is we get the data very quickly by using just the script that we have here available in the oops, I think I have to just, this was a bit maybe too long idle. We have basically in the script the data available that we can download from Keras, and it should look a little bit like this, but we want to prove that it really looks a little bit like this that you see on the slides. So we expect something like 28 by 28 pixels, so a 2D structure, where of course this is an image, and it should be having grayscaled values, basically where we obviously want to see a digit on. And of course, it's not always the same digit. People write this differently. And the idea is then, of course, can we find a machine learning system as a business that actually can recognize these numbers? And of course, we want to do this in the high possible degree of accuracy. So what is the best model we can have in order to do that? So the modeling will be coming up from lecture 2 to 3 and so on. So we jump then a little bit, make first the introduction to cloud computing properly in the next course hour. And today it's just a little bit the preparation of saying, what can we do for exploration, right, of this particular data set? Now, the idea is here to look a little bit into Keras and use basically import MNIST, which is this data set idea. So in the end, the Keras distribution has already very interesting data sets that are often used in tutorials, which you can simply download by just having the import MNIST. However, of course, that means Keras needs to be installed on the system, which might be not the case. And as I told you, there's an option that if you have it maybe on Anaconda or whatever you have in terms of environments, and there's something not available, you can usually install it quite nicely with a pip command. You see that a little bit here, the pip install -- user Keras. Right here, for an example, in the cloud, where you can then basically, if you re-execute that, once you have installed that, be really able to use that particular package. So the pip install command is very important. -- user depends a little bit on the right setup you have, mostly on remote cloud setups. And it's an important tool to look a little bit on it because it has lots of things to do with different Python packages that you usually can install very nicely into your own environments. So let's see if the cloud has come up again. Okay, so it seems to be active again. So let's go to the pre-processing. So here again, I'm in the Jupyter JC remote one. Okay, let's see what's happening here. Is that really a big issue? Otherwise, we restart the whole thing again. So here you see the same statement in the cloud. You see here in Jupyter JC in the URI, I'm basically really remote and try to execute this now. I have done the step already with, pip install, or the cloud has already the Keras available, and we have imported now the MNIST basically. So the data set is now on the hardware there remotely, not downloaded for you locally here on your laptop, but it's available in your own local environment in the cloud. Now there are a nice command like here where you train and test, or you basically cut the data set now in a training set and a test set. This is not so obvious to you. We will see how that materializes coming up from lecture 2 again, when we start with the basics of machine learning a little bit with big data. But in the end, it's something which we always have to see. There are two processes. Let's see, seems a bit weird today. I think it's still going to work. It's another element here that we don't need right now. As you basically have now the idea of looking into the idea of one character here in this particular function. What we want to do here, for instance, we see in the training set, and use this kind of function to really inspect the data, do data exploration, look essentially if basically it looks really like that we said. Important consideration is that there's an X train, which is basically this image you see now here with the 28 by 28 pixels, as we said, the gray values that we see here from 0 to 255. And then essentially the intensity, of course, is in the pixel values here. So that means people write differently the same label. And also, of course, the format, which of these kind of metrics is so to call filled. So now we understand the data much better. We have an exploration idea, and we have also basically, some trouble in the moment with this Jupyter, but basically it works. That's good. I think it is a new version of Jupyter that's why here and there not everything works and smoothly. But essentially, you see still we can execute this very nicely. We have a label here, which is 5, which means now the Y that we have here, meaning it's a supervised learning environment. So we have a data set that has labels. That's why we called it a labeled data set, to really show already this is something where people thought it's a 5. This is a 0. This is a 4. And you see, of course, when you look maybe a few meters distance from your screen, it is looking like a 4. And of course, this could be a 1, although it's really not really straight, right? So it's, of course, how people write different numbers. And the idea is now, can we have a machine learning system that learns from it how to really automatically detect, is this a 2, is this a 9, out of this handwritten variety that people have. So here's a 3, for example. And you can go on. We go here through the whole set. This is the idea now of the data understanding phase and also the exploration inside the data set. And something like this is, of course, now important to do, because when we want to use now cutting edge deep learning, if you want to use neural networks of sort, we have to understand the data structure. For instance, neural networks, the traditional neural networks with feed-forward models we will talk about in upcoming from lecture 2 and so on, is basically receiving a 1D input, one-dimensional input, but we have a 2-dimensional input here. So we have to vectorize certain things, but this is things we do later. But of course, in this sense, Python, you see just with a couple of lines, really 10 lines here, maybe 15. We already have a data exploration script that easily goes into the data, can load the data very nicely. And, we understand the data in this Jupyter environment quite nicely as well, having directly output to our execution in each cell, which is a very beautiful way of inspecting and exploring the data. So I think so much for this part. Let's go back that I have the same also for you, of course, in the slides. So essentially, that's a little bit what I already talked to you. The different phases will be important for us later, the training and the test set, that we basically always have this training example, but this means we have a 2x2 image here, and this has really the guiding label Y, which means, it's the 5, it's a 7, etc. While the X is now this 28 by 28 pixel input of gray values. The way how you cut them is not always, obviously, we will always, talk about this. It's basically here and there rule of thumb. Take the less you can have for training, but not less or too little. This has something to do with statistical learning theory, that you still need lots of training samples to have a proper model. But in order to validate and to test well your model, you also should have a very proper test set that you throw in the corner, never touch when you do the training and validation of your data sets. And these are, of course, elements that a proper machine learning course can go into different lectures. In my courses, I usually spend for training and testing at least just 2 lectures, and then for validation, which is model selection in a way for parameter checks and so on, another lecture or 2. So here you have to really, in a proper machine learning, spend much more time to understand these elements. But there's not really a clear separation. It really depends how much data you have. Of course, in big data, the more data you have, the better it is. then of course you can have maybe different validation sets, one proper test set thrown in the corner, never touching until the very end, where you test your model for practice and so forth. But we also will touch base on these ideas of training, testing, and validation later, just that you know why we basically have now here cutted it in test and training, because we want to, based on these examples, we'll follow on with lecture 2 and 3 later, when we clarified the basics of cloud computing again, to use the same examples throughout the course. Good, but I think that's pretty clear now. Let's have the last parts really maybe on something which is also very practical. Here you have association rule mining as an example. Also there will be a complete lecture on it to understand what are association rules. Basically, you can see a little bit the idea of saying that a pattern in shopping data exists. So the way how maybe, you know, kind of some certain elements that a shop offers, we call that frequent item sets, as very special. So there's some of them that are often bought. And of course, those which are often bought are an important part. But we also want to understand, is there maybe a kind of association? So in the end, is there a relationship to those frequently bought that we can say, you know, if you buy this particular product, chances are that you also buy that particular product B. And this is, of course, for shop owners, a very beautiful information. You can imagine that once you have that in your shopping basket, a recommender engine pops up and says, because you bought this product A, we are very certain that you like product B. And many customers from us that bought product A also bought product B. And of course, this is something that Amazon and these big players from the shopping already do since a long time, right? If you go now to Amazon, you will see exactly that information encoded. Other customers also bought, which is basically the idea here. It's still not personalized recommenders, which are much more stronger, and we will also have that a little bit in the later part of the course as applications from lecture 11 on. But here's a very simple example, really, again, that's why I bring it early in the course, how you can do with a couple of lines really a very powerful algorithm in machine learning by using a beautiful way of, you know, pandas combined with NumPy combined with Python, and a little bit of a Python library setup that you can easily install for free as open source. And suddenly you can have, let's say, a real shop informed on that, given, of course, he gives you data. So there's several implementations of these association rule mining. We focus here shortly on the a priori, but there's an FP growth that here and there scales a bit more because of its more tree-based structure. This is also something coming up more in lecture 11 that I cannot present here, and Mafia and others. So here really is the thing that I already mentioned. So you need a purchasing behavior, hopefully between the different market baskets. So you assume you have some transactions that we have here. And I alluded already at the prologue, there's a certain very glorious examples of diapers and beer, right? This is a shopping list of items. You see bread and milk bought, bread, diapers, beer, eggs, etc. So you have all these kind of market basket transactions from people going out of the shop. And now the idea of a frequent item set would be, you know, kind of, okay, diapers and beer are incredibly often bought together. And so we can make out of this an example of an association rule of saying everybody who buys diapers usually buys beer. And, you know, the origin, as I told you, as a kind of riddle, is that essentially I think this came out of the UK, they are very much pub oriented. So that means it's a culture that often goes to the pub in the evening just for a beer to returns home. But if you have a small kid with diapers, you can't really do that necessarily every time anymore. So you buy much more beer. So this is kind of stand the test of time, this kind of rule. But obviously, we don't want to do it just on beer and diapers. So you can do the same idea now on many different ideas and then offer them for cross-selling. Once, of course, you have, let's say, put diapers in, chances are that you can do it in the shop, or basically in online shopping these days a lot recommend beer to put in your basket, and chances are, because many people did this, that you would do it as well. And of course you want to have it as an automated process and as a scalable process, and that's the point in the course that we will learn. So in order to compute this, here we now use it quickly with Python MLX10, but of course in high performance computing, you can really scale that up to many, many transactions that your laptop otherwise cannot digest. And with this, have a very scalable solutions, basically usually using FP growth and other implementations. But we will come to that in later lectures of the course. Let me just do a little bit there, the kind of example demonstration here. When we come back to the local environment here, I have this example also loaded up for you, by the way. So you can also play with the data. It's a little bit of fake data based on parfumery, where we had really interactions with. And here you see the beauty of Python. Again, when we have this particular script loaded, we basically have here a couple of libraries we make use of, pandas, NumPy, as we already discussed. MLX10 now is an example where you may have to install it using pip, right? An important part of it. Matplotlib could be, for instance, another interesting, powerful package, not really used now here, but could be something for plotting, often used. You see here how nicely it is with the pandas data frame reading from a CSV file. And of course, how such a file looks like is best explained if you look into it. Nothing else than shopping basket, no diapers and beer this time, but Hugo Boss, Chanel, perfumes, brands, a little bit simplified, that there's just one occasion from each of them. Obviously, Hugo Boss has many different perfumes or so, but here we keep it very simple as an example. And then lots of these transactions. And now you want to find out of these transactions, what could be the best recommender, right, out of this. And clearly, the human eye now is a little bit overcommitted. The shop owner, maybe with spending an hour looking at these, would identify these things a bit better. But in Python, we just quickly go there. We will go to our script here, association role mining. We will read this data in. We see already this is basically nothing else than this kind of shopping data we have seen just now. NAN means there was no item at that particular comma, so to speak. So no, just a 3-item shopping basket here. We can do things like with a data frame to understand which of them are unique. So what is the, obviously Hugo Boss was often shopped, Bioterm often shopped, etc. But what are all the different, let's say, types of one object in this, which is very nice sometimes to analyze the data further. And here we see a little bit an interesting helper script, which is quite powerful and often used in machine learning, which has something to do with the idea how the algorithm actually is operating. We call this a one-hot encoding. And you see that a little bit basically here, that essentially you're building a matrix with all the different unique products on the one hand, and then you have still the different, let's say, different transactions on the other hand. And you basically just do the occurrence. So every time when there was a comma and saying DO was shopped, you do a 1, if not, a 0. Right? So it's another data representation. And that is now what we meant with the data preparation phase in the CRISP model. So instead of, this is the data understanding phase here, right? We look at it, we see how much is unique, but now we really transform the data into a data structure in a data frame again with encoded items, which we can use then with the a priori algorithm, which is an association rule mining algorithm to find the frequent patterns, right? And the frequent items. So see that here a little bit. So we have here the basically one hot encoded data frame that we generated here, put as an input now to this frequent items algorithm to find them. Now this is already interesting for us. So we see that with the support of 0.7, Clinique is obviously very often bought. And now the association rule between them and the shopping basket, we can run some association rules based on these frequent items. There are lots of different configuration parameters we can basically configure, which we will do then in lecture 11. So it's nothing for today, but you see with a couple of lines of code here, I can tell the shop owner already with the support of saying, with the highest support maybe here, and the confidence, a high confidence as well, that basically if you buy Bioterm, the chances are that basically he will also buy this Clinique. Now, this is a more or less toy data set, and you see already chances are that it's always Clinique. But here you have a very, let's say, higher supported confidence. And there are several elements that we talk about in lecture 11, then talk about leverage and conviction that I will basically skip here a little bit. I put some of them a little bit into the slides here just to have this practical part a bit, basically understood from some examples, but essentially it's the same thing I presented with the PEPR example here of Parfum. But the point is really with a couple of lines of Python, you have a very powerful tool really already for shopping owners. And you can really see that they makes a difference in many different, let's say, branches of retail, at least, to know what people may want to shop. This was the example with the different elements. Of course, the practical approach is that there are lots of these rules, and we will learn a little bit in lecture 11 how to be simpler, how to make less rules, and those focusing on those basically with high confidence and high support and so on. All right, so I think with that, I showed you what I can in Python in a very short amount of time. Obviously, a proper course here in Python would help much more than I could possibly show you. But in the end, I hope it was a bit useful, and we break here again for roughly 5 minutes to 10 minutes, and then can go to a Q&A session where you should maybe also try to basically explore Python a little bit on your own. So see you then.